Context-free grammar. Now let's see about what is maybe context-free grammar. Context-free grammar is called as CFG in short form, and it is a formal grammar which is used to generate all possible strings in a given formal language. So from this grammar, like how from English grammar or Tamil or any language, we are able to generate the strings and sentences from given defined grammar, we are able to generate the language. Likewise, from the formal grammar, given grammar, we will be able to generate all possible strings of a given formal language. Such grammar is called as context-free grammar. So the context-free grammar G is defined by tuples called G equals B, T, P, S. So the grammar is defined by four values V, T, P and S. V is nothing but V is the set of non-terminal or variable list. Non-terminals are normally represented by uppercase letters. So the default rule, so to use the uppercase letter to represent the non-terminals. So it indicates V may contain a set of capital A, B or S or Y or any uppercase letters are used to indicate the non-terminals. And then we have T. T is the set of terminals. It belongs to the alphabet set. And all lowercase letters are used to represent that it is a terminal. So when you take the terminal T may contain all possible lowercase alphabets A, B, C, D like that to Z. In addition to that, if I want to include the number 0, 1 to 9 and my special characters or operators like plus, star, minus, like this, all the symbols can also be included in the terminals. Remember, all uppercase letters always represent non-terminals, whereas lowercase alphabets or symbols represent the terminals. And in addition to that, we have one special notation called S or start symbol. It is the starting symbol of the grammar. To derive a string, we have to start. There is a starting location, the starting point. It's called a start symbol. Always we will start from the start symbol. In the grammar itself, they'll give the start symbol where to start. In addition to that, we have the production rules. So the production rules are in the form of alpha to beta. That is, it gives the transition from alpha to beta where it is used to derive the strings. It maps the relationship between the terminal and non-terminal characters. So we need the set of non-terminals V, terminals T and start symbol S and production rules. These four will constitute a context-free grammar. So we can derive a string by repeatedly replacing a non-terminal by the right-hand side of the production rule until all non-terminal have been replaced by terminal symbols. So it means that my string, my derived alphabet string should contains A, B, C or AA like that. It must consist of purely of lowercase letters, that is terminal symbols. It should not have like A, capital B, C like that. Here capital B is a uppercase letter which indicates a non-terminal. So our objective is to reduce the everything to non-terminals to terminals. That is how we are going to derive a string. So it is possible to generate all possible patterns of strings in a given formal language. Let us see one small example. Here given construct a CFG for a language having any number of A's over the set sigma is equal to A, where the regular expression is given by A star. A star indicates it has all possible combination of L contains epsilon. It contains, it's a clean closure. That means it may or may not have. So it includes the null symbol and all combinations of A. So single A, double A, triple A, quadruple A, like that infinite length. It indicates all possible combinations of A including null. So it is a clean closure. Okay. So it can be defined by production rules. There is a grammar as two grammar rules and we are normally having the practice of naming the grammar production rules by numbers. These numbers are used to follow up the input derivation in your problem. First rule is S maps to AS. That indicates that wherever I can start symbol S, I can replace with AS. The meaning of this, S can be replaced by AS. Now, we are going to derive another rule is S belongs to epsilon. That is, S can be replaced by the empty character called epsilon. Now we are going to derive the string AAA. I am going to derive AAA out of all possible strings. Now we are going to check whether it's possible to derive this AAA. So now let's start with the first start symbol S. S maps to AS. Now I am applying the production rule 1. So the production rule is 1. By using production rule, S is replaced by AS. Now I have one terminal character A. Second one is non-terminal character. So the second step, I have to replace this non-terminal character by another character. Objective is the output string should be of only of terminal characters. So again I am going to apply the first production rule because I want 3 A's. Okay. So I am applying again I have so AS by using the same production rule 1. Now I have 2 A's. What is my objective? I need to derive 3 A's. So again this A will be replaced by AS. Again, I am applying the production rule 1. Now, what I am having? AAS. But what is my requirement? It is only triple A. So, I have to make this S to disappear. How it is possible? We are having one more production rule that S can be mapped to epsilon. So, I am mapping it to A epsilon using the production rule 2. Actually, epsilon means null. Am I right? It's a null string. So there is no need to replace. In other words, I can directly interpret this as A because epsilon means it's null. So here I got my final string as A. So this is how I am able to generate an input string from the given grammar.